Alright guys, so long time no see, and today we're gonna do something related to the more complex the chain rule about derivatives. So here's a table, and we're gonna use the table to find out the value of each derivatives. Alright, let's see. Let's start. So for the first one, d over dx of f plus g when x equals to 1. So for this one, it's really easy because there's no chain rule applied to this question. What we only have to do is we're gonna just plus derivative of f and g, so it becomes to d over dx of f plus d over dx over times g, and when x equals to 1. So eventually it becomes to f prime of 1 plus f g prime of 1 becomes to f prime of 1 is -3 plus g prime of 1 is 2, it's -1. So the next one, we're going to use a chain rule here. So the chain rule basically, if we have to evaluate the value of f, so g is embedded in f of x. The chain rule will be f prime of g of x and it times g prime of x. So for this one, what we got is f prime g of, because it's asking us what's the value of when x equals to 0, so it's f prime of g0 times g0, g prime of 0. Alright, so f prime of g0 equals to 1, so f prime is 1 times g prime 0, it's -3. F prime of 1 is 1, so 1 times -3 is -3. For the next one, so you're asking us the derivative of 1 over f minus g when x equals 2. So for this one, it's a quotient rule. We do 1 over. It's actually still I mean, you don't have to do quotient rule. Instead, we could use chain rule to this one. So it becomes to f minus g to the -1, and we apply chain rule to this function. What we got is -1 f minus g to the raised to -2 times f primes minus g primes. So it's asking us a value of x equals to 2. So what we have to do is find out the f of 2, g of 2, f prime of 2, and g prime of 2. So -1, which is, we can ignore that. So we negative f2 minus g2. f2 is 5, g2 is -2, so it's -7 to -2, and times f prime of g, f prime minus g prime. F prime is f prime of 2. F prime of 2, it's 0. I mean, f prime of 2, it's 5. Oh, f of 2. Sorry, guys. F of 2 is 0. F of 2 is 0. So it's -0 minus g f prime g2. G2 is -2, so it's 2 times f prime of 2. F prime of 2 is 5 minus g prime of 2. It's -1. So we got is -1/4 times 6. So it's -3.5. So next one, we still use a chain rule applied to it. So it's d over dx f plus g to a half, And what we got is we just use chain rule, so what we got is a half times f plus g and times negative a half and times f prime plus g prime. So what we can do is f of 1 plus g of 1. f of 1 is negative 2. Negative 2 plus g of 1. G of 1 is what? G of 1 is 5. Oh, sorry, my bad. 2 negative a half and times f prime of 1 plus g prime of 1. F prime of 1 is 1, g prime of 1 is 0, so it's times 0. So it becomes 2 times root 3, because there's square root and negative 1/2, which is you got the square root of it, and you flip it to the denominator, and it's over 1. 1 over root 2 of 2 times root 3. For next one, what we got is, so it's basically not chain rule. We call it, it's not a quotient rule, but so you multiply these two functions. Sorry guys, I forgot a specific term for it, but I do know the equation to solve the question. So basically the equation is, if you gotta find the derivative of a function times another function, what we have to do is f. So the original, for you this one example, it's f prime times g and plus g prime times f. So acting as the value when it's 0. So f prime of 0 times g of 0. F prime of 0 is 4. G prime of 0, g of 0 is 1. So for this one we got 4. And plus the second one is g prime of 0 times f of 0. G prime of 0 is negative 3, and f of 0 is 3, so it's times negative 9. So it's negative 9, so plus negative 9, the answer is negative 5. Alright, next one, so you're asking us a derivative f squared. So when x equals to 2, so it becomes f prime of 2 d over dx f prime of 2. So we have to do is still the chain. It's a chain rule. So 2f, I mean, it's not chain rule. It's a basic law of the derivative for the exponential. The basic law for derivative for exponential function. So we got it's 2f, 2 minus 1 raised to 1. So 2f of 2, it's f of 2 is 0. So the answer is 0. I hope you guys enjoy this video, and I'm gonna do furthermore later on. So see you next guy. See you next videos. Thank you for watching.